Okay, this week we are going to talk about exponents, and this is going to be more review from intermediate algebra. But by the time we get to the end of this unit on exponents, we're going to be doing stuff that you haven't done before, and it's going to be pretty challenging. So, knowing these things that we're going to do in the first 2 days of exponents is super important because it'll help you out a lot down the road. First thing we want to simply just talk about is evaluating expressions that contain exponents. And the only thing you really need to know is that an exponent tells you how many times to multiply a number or a variable by itself. And what we call that number or variable is the base. We might not use that term very much, but you're going to see it throughout the course of your math career, and you're going to want to know what that is. So the base, if we look at the first example here, we have 2 to the third power. The exponent is 3, but the base is the 2. So it's whatever number has the exponent on it is considered the base. And in this case, it's 2 to the third power, so it's telling us to multiply 2 by itself 3 times. So we would say 2 to the third power is 2 times 2 times 2, and 2 times 2 is 4, and then if we multiply by another 2, we get 8. Okay, so 2 to the third power is 8. Okay, now the next two examples are going to illustrate something that is super common. It's a super common place for you to make mistakes. If you take a negative number and you take it to a power of some sort, so this in example B, it's -4 to the second power. Since there are parentheses there, that means that we multiply -4 by itself twice. Okay, so we're going to say -4 times, and I'll put the second one in parentheses just to keep the symbols kind of a little neater. So it's -4 times -4. Well, negative times negative is positive, so it becomes 16. Okay, so anytime we have parentheses, we include the negative sign with the number. Now, if you look right away at example C here, we don't have parentheses. And the way I want you to think about this is if we have -4 to the second power, I want you to think of it like -1 times 4 to the second power. And the exponent is only on the 4, it's not on the -1. So what we have is we have -1 times 4 times 4. And 4 times 4 is 16. So we have -1 times 16, or -16 in this case. Okay, so it's really important to know the difference between these two, where we have parentheses and we don't have parentheses, because it's going to be a really common place where you're going to make mistakes. Okay, so let's keep going. Look at another example. So in this case, we have a fraction. Anytime we have a fraction to a power, we simply just apply the power to both numbers inside the fraction. So another way we could think about writing this is 1 to the fourth power over 2 to the fourth power. And so then we just take 1 to the fourth power. Well, it's just 1, right? So we have, that's going to be equal to 1 over, well, 2 to the fourth power is 2 times 2 times 2 times 2. Well, we did 2 to the third power in example A. 2 to the fourth power is just one more 2, so it's going to be 8 times 2, or 16. So we have 1/2 to the fourth power is actually 1/16. Okay, couple more here. Decimals. If we take a decimal to a power, a decimal is just another form of a number, but a decimal to a power does something weird. It actually gets smaller and smaller instead of bigger and bigger. Like if we take an integer to a power, the answer gets bigger and bigger, whereas a decimal to a power gets smaller and smaller. And so we have 0.5 to the third power, so we have 0.5 times 0.5 times 0.5. Okay, so this is basically saying 0.5 times 0.5, well, that's 0.25. Another way to think about it is, what's half of a half? Well, half of a half is 0.25, or half of 50 is 25, so it's 0.25. And then we multiply that by a half again. Well, half of 0.25 is 0.125. Now, I can do that in my head. Maybe some of you can, but if you can't, I wouldn't worry about that. because we have calculators and they are perfectly fine to use when we're dealing with exponents. And actually, I would highly recommend it because it really saves you from making some mistakes. Okay, the last example in evaluating expressions, it's right beneath the one that we did with the -4 squared or -4 to the second power. Um, and there's a reason for that because when we have 4 times 3 squared, what a lot of people like to do here is they like to multiply the 4 times the 3 and then take it to the second power. But just like the example right above it, the exponent only applies to the 3. So we have 4 times 3 squared, or 4 times 3 times 3. And 3 times 3 is 9, so we have 4 times 9, and 4 times 9 is 36. Okay, and that would be significantly different if you did 4 times 3, which is 12, and then took it to the second power. That would become 144. So completely different numbers. So I just want you to remember that if there are no parentheses around the two numbers, in this case the 4 and the 3, there's no parentheses around them, so the power only applies to the 3. Okay, and we're going to run into that a lot. We're going to run into a lot of situations where we have powers on variables with a coefficient in front of them, and the power only applies to whatever it's on and not the coefficient that's in front of a variable unless there's parentheses. Okay, so just that idea of parentheses is super important. Okay, let's see here. Can I do this? Yeah, there we go. All right, so a few rules that we need to remember from intermediate algebra. The product rule. The product rule, product means multiply. So anytime we see a base with an exponent and the bases are the same and they're being multiplied together, in this case we see things that are right next to each other, so that means multiplication. So anytime we see that, we are going to keep the base the same, but then we're going to add the exponents. Okay, and you can see in the little description there, we use variables and letters, the letters M and N. And sometimes that's just kind of confusing because it's a bunch of letters, but you can see all we're doing is we have a to the m power and a to the n power, and we're simply just adding those two exponents together and keeping the a the same. Okay, so I don't know why it likes to do that, but here we go. So if we have 4 to the second power times 4 to the 4 to the fifth power, one way to think about this is 4 to the second power is 4 times 4, and 4 to the fifth power is 4 times 4 times 4 times 4 times 4. Now, we don't want to have to do that with everything that we do, especially ones like, well, the one that's right below it, the y to the third, y to the second, y to the seventh. We don't want to have to do this for every single one of these problems because that would just become painful to have to write all that out. But on this first one, we can look at this and say, all right, how many 4s did I write? Well, I wrote 1, 2, 3, 4, 5, 6, 7, right? So I wrote 7 4s. Well, 2 plus 5 is 7. So that's how the product rule works. So if we have 4 squared times 4 to the fifth, it's the same as 4 to the 2 plus 5, or 4 to the seventh. Okay, and we generally don't always write this part out like this. We generally can look at this and just do it in our head and be able to see that 2 plus 5 is 7. So we can kind of skip this middle step in writing it down and just go right to the answer usually. Okay, so if we look at example B, we have x to the fourth, x to the sixth. If we just think about it in our head, the x's are the same, so the bases are the same. So 4 plus 6 is 10, so we can just simply write this as x to the 10th. Okay, similarly, we have y to the third times y. And this is one that kind of catches people sometimes because they don't remember that there is actually an exponent on that second y. It's a 1, and we need to add that together. So it's y to the fourth power. Okay, so if we keep going, we can have more than 2. We have 3 in this case, and I already mentioned this one briefly. Y to the third, y to the second, y to the seventh, they're all multiplied together. We could write the whole thing out if we wanted to, but I can look at this and say, hey, there's going to be 12 y's that I have to write down, and I don't really want to have to do that. So I'm just going to say I know it's 3 plus 2 plus 7 or y to the 12th. Okay, and similarly, we've been dealing with variables, well, except I guess the first one was a number, but with this one, we have -5 as our base. We have parentheses, so that means it includes the negative sign. So we're just going to keep this all exactly the same, and we just add those two exponents together, and 7 plus 8 is 15, so I'm going to write it as -5 to the 15th, but keep the parentheses. All right. And then the last one, this one is here just to illustrate the fact that the bases need to be the same. So if we have an a and a b for our bases, they are not the same. So I do not want to add these exponents together. So if you see something like this, there's nothing we can do but leave it exactly like it is. All right, let's expand on the product rule a little bit. So if we want to expand on the product rule, one thing that we need to think about is something that I mentioned earlier, and that's coefficients. And a coefficient is any number that is to the left of a variable. So in the case of the first example, we have 2x squared. Well, the big 2 that's on the left of the variable x is a coefficient. Or we have 3x to the 5th. Well, the 3 that's to the left of the coefficient, or sorry, to the left of the x is the coefficient. So it says here, still keep the base the same and add the exponent. So we still do exactly what we have been doing with the product rule, but this time we want to multiply the coefficients. All right, so in this case, we have 2 and a 3 for our coefficients. So one thing that you can do is you can rearrange things, and you can say, all right, I have a 2 and a 3. They're both positive, so I don't really necessarily need parentheses here. So I just need 2 times 3. And then I have x squared x to the 5th. Well, 2 times 3 is 6, and the x squared x to the 5th is x to the 7th, so I can just write it as 6x to the 7th power. Now, some of you are going to be tempted to apply that exponent to the 6, or even up above, you're going to apply the exponent of 2 to the 2, or the exponent of 5 to the 3. We don't want to do that because the parentheses are around the whole thing, but they're not between the exponent and the variable. Now, if that right-hand parenthesis was between the exponent and the variable, so if it looks something like this, then that exponent applies to both things. But since that parenthesis is outside, wait a minute, I just wrote it again. Since the parenthesis is outside, that exponent only applies to the x and not the 3. Okay, so let's keep going here. All right, so just increasing level of complexity, right? So in this example, we have a coefficient, we have a -4, but there aren't any other coefficients, so we can just write that one. We know it's going to be -4 something. And then if we want, we can rearrange things. But again, I think if you can start to look at these and do these in your head, that would be really helpful because it's going to allow you to go more quickly through some of these. And I know speed isn't necessarily a good thing, but it's like you're going to have times in the future where speed is going to be important, especially if you take something like the ACT exam where you have a limited amount of time to do a certain number of math problems. So I have -4, and then I wrote down the x's, the x squared and the x to the 3rd, and then I have y to the 1, that's my first y, and then y to the 2nd. So get into the habit of writing that 1 when we're dealing with exponents until you're just super confident that you're going to remember that there's a 1 there, because otherwise you're going to forget, and you're going to be off by 1 in your answer. Okay, so we have -4, x to the 5th, y to the 3rd. Okay, and then the last one, this is one that kind of tricks people up sometimes because it's -a to the 7th, b to the 4th. Remember, we can rewrite this now as -1, a to the 7th, b to the 4th times 3ab to the 9th. And I did that because it's easy to forget that there's a coefficient where that -a to the 7th is. And so if we write that 1 in there, we know we have -1 times 3, so that becomes -3. And then we have a, I'm going to put a 1 on that a, so I remember it's a to the 8th. and b to the 13th if we add those exponents together. Okay, let's keep rolling. Oh, no, we're done. All right. So down here, it says what your assignment is. And in Schoology, there'll be a worksheet just like in the past. And it's going to be from the textbook. And the thing I just want to clarify here is in the past, some people have done all the problems from 7 to 21 instead of just the odd ones. So you want to do only the odd ones. So you're going to do 7, 9, 11, 13, and so on until you get to 21. So just make sure you understand when it says odds like that, or if it says evens, you're doing only the odd or even problems. You're not doing all of them. And then even some people took it even one step further, and I thought this was kind of funny. They only did 7 and 21. They didn't do anything in between. So make sure you do the stuff in between too, but not all of them, unless it says all of them.